Hello, everyone. My name is Ryan Boyd, and I'd like to welcome you to our webinar today on lesser known features in Cypher. My name is Ryan Boyd, and I am on the developer relations team here at Neo4j. And I'm joined today by Alex Price, who's an engineer at Neo, and we are very excited to bring you today's presentation. As a few housekeeping items before we get started, we'll invite you to submit any questions that you have throughout the presentation using the questions box of your GoToMeeting or GoToWebinar control panel, and we'll answer as many of these questions live as possible at the end of the presentation. Lastly, a on-demand recording of the session will be made available for you, as well as the slides for your leisure, so you don't have to hurry and scribble down all of the Cypher statements that Alex will be showing you. And we encourage your participation during this session, as you'll have all that information available. You can also check out neo4jsandbox.com, which is something we just launched last week in alpha mode. And neo4jsandbox.com will allow you to get up and running with a Neo4j instance in the cloud, and you can experiment with some of these features that Alex is talking about. With that, I'd like to hand it over to Alex, and he can get started. Alex.
Hey guys, good morning. Thanks for joining us. So as Ryan said, I'm a field engineer here at Neo4j, and as such, I spend a lot of time working with customers. So I'm hoping to share a few tips and tricks here that can help you out. So maybe these problems and these questions you don't need to suffer through quite so much. So some of the topics we're going to be talking through today are a little bit advanced topics. I think you should be able to find things that you should find useful at any understanding, any comfort level of Cypher today. So if not all of these things make sense to you, hopefully a few of them stick and are quite helpful. So without further ado, let's get started and look at the summary of topics we're going to be looking at today. So we're going to be looking at the query plan and what you want to do when you're going through to profile your query to understand exactly what's affecting the performance. We're going to look at how you can affect the plan manually and force Cypher to behave in certain ways. We're going to be looking at some of the internals of Cypher, how we can change the version of Cypher being used, for example, and what the point of that would be. We're going to look at eagerness, which is an aspect of the query plan that has significant impact on the amount of memory used by the query. So we're going to look at that and how to optimize the eagerness out of the query plan. We're going to look at using Cypher to calculate the distance between points. And then we're going to look at a few common patterns in Cypher that I see. So you should be able to take those and apply them to your domain model, hopefully. So the first topic is about getting the execution plan. And this is about how the Cypher planner turns your Cypher syntax into an actual execution plan on the server. So the two keywords that you would be using here are the profile and the explain keywords. The difference here is simply that the profile keyword will actually execute your query, whereas the explain keyword will not. The significance of that, beyond just returning results or not returning results, is that the profile keyword will let you know the number of rows being affected by the operations. It doesn't have to estimate those rows. It has the actual rows from performing the operations. So generally, I find that people will use the profile keyword 99% of the time, but be aware the explain keyword is there if you don't want to execute the query. So when you're visualizing the execution plan, in the browser, it gives you a nice visual where you can start at the top and see how it flows down toward the final result at the bottom. If you're going to copy and paste the execution plan into our Slack channels for help, you're going to want to expand all of these boxes so that we can see what's going on inside each individual step. There's also the Neo4j shell where you can execute this profile and get back a text-based response. This is also very helpful. It's all of the same content. It's just not being displayed in a visual manner. But this is read from the bottom to the top. So it's the same content. It's just read in a different direction. So things that you might want to watch out for in a query plan. You almost always want to be starting with a node index seek. So if you aren't using indexes to begin your query, you probably should be creating an index and making sure that when you search up the property of that indexed node, you're referencing the label that property belongs to within the pattern expression. You want to avoid large Cartesian products and joins. The browser will actually give you a warning if you have Cartesian products, but that's something where you're searching for two different items, each of which return multiple results. Cartesian product will be a product of those two, resulting in a large expansion of rows. So you want to try and avoid that. You want to try and avoid the number of rows proceeding from operation to operation. Eager aggregation is something that you want to try and avoid as well. It's where we have to compute the entire intermediate result set before continuing along with the query plan. And we'll talk about that in a little bit more detail. Duplicated operations. You want to try and reuse nodes that you found earlier in the query without having to relocate those. So being able to collect nodes that have already been found and pass them forward to future operations is very efficient and helpful. Label checks can be removed quite often if you know that the only path to that node is through a specific relationship type and there's no other label that that node could have. You can sometimes see improved performance by removing these label checks. Overexpansion, so it's a good idea to make your relationship types as specific as possible. If you have a node connected to many other types of labeled nodes, and all of those relationships are called connected to, every time you expand out that node, you'll get to a bunch of other nodes that you may not be interested in. So using specific relationship types greatly increases performance by reducing the amount of nodes you end up having to exclude later due to not having the correct label. So if you can use a specific relationship type, you can work more efficiently toward your solution. So here are a few IndexHansel. So if you want to manually affect how Cypher is going to execute your plan, these are some things you could do. And so I'll talk about these each in detail. So the using scan keyword, and you can see an example Cypher at the bottom of the column, is used to force the planner to start on a specific label scan. So in this case, we have the labels person and Olympian. So when would you want to use this? You'd want to use it when the label would be more selective than the index. So in this example, there are a lot more people of the age 18 than there are Olympians. And so being able to force it to use the label Olympian would result in a smaller search space. You're going to start with fewer rows. And sometimes understanding when to use a scan hint like this versus not is dependent on an intuitive understanding of the data. Like, for example, that there are fewer Olympians than people age 18 in this context. So the idea behind using index is similar. It's where you would want to force it to use the index to begin the query operation. And that's when you know that the index would be more selective than some other particular index or a particular label scan. So in this example, we have two labels, person and parents, and we're saying that we only want people of age less than 16. So the Cypher Planner is actually pretty good when it comes to equality in determining uh, in determining the selectivity of the index. However, when we're doing a range comparison here, where we're saying the age less than 16, it's not possible for it to determine how selective that particular range query would be. We happen to know that there are fewer people under the age of 16 than there are people who are parents, for example. And so we can say that that's going to be a more selective operation than the parent label, and we can force it to use that particular index. However, note that when you do these kinds of things, if the underlying data changes, for example, you get an influx of persons in the database under the age of 16, that calculus could change. And the third one is using join. This is forcing how a join operation takes place. So if I take a step backward here, actually back to using index, there's the third bullet point. I'm talking about how we can use multiple indexes on a plan. So it's possible in a pattern match that goes from A to B to C to D to E that we can say we want to start with both A and E using an index on both ends of the pattern match. Those two ends will come together at a point, and the cross section, say from A to B to C, will be matched against E to D to C, and this is called a join. So the third index here is allowing you to indicate how that join should take place. Now, typically, the planner will make a good decision in terms of the cardinality of the nodes, basically how many different relationships of that type are connected. It'll use the metrics we have in the database to make an intelligent decision on how to join. However, you can force that. For example, if I wanted to go from A to B on one side and from E to D to C to B on the other, and then join on B, I could use the using join hint to force that to happen. It's not a very common use case compared to the first two, but it is a possibility that could help you. So the last hint here is to use hints with caution. The planner will take the selectivity of an index into account when evaluating equality. So what I mean by that is if I were to say age equals 18, it has a very good idea of how many rows that will end up returning. If I say age is less than 18, it can't really estimate how many rows that might return. But as far as equality goes, it's very good at making that decision for you. Forcing a plan means that the planner cannot adapt when the underlying data changes. So you could put something in place today that ends up not being true tomorrow. And it's something to watch out for. It makes your application more rigid, and it also means that future improvements to the Cypher planner logic might not be incorporated into your query quite as efficiently. Your plan might be more efficient specifically while being less efficient generally. So if you're testing a query plan using IndexHints, you want to make sure that you're testing against a broad spectrum of queries that will be affecting your production applications. So hints can inform the planner about the structure of your data in ways that the planner cannot infer itself. And so this goes back to, for example, age is less than 16 being something that it cannot infer. So if you're able to infer some of these things as resulting in a smaller search space, then it helps to inform the planner of such things. And if you do use hints, use them to force a plan around aspects of the data model that will remain relatively consistent. So plan for change and keep in mind that these hints that we're using are generally only going to be applied to the top 1% of your queries that you're really trying to get the most performance out of. So here's an example of using multiple indexes. The first query, and this is running against the default movies data set that comes with Neo4j. The first query here is searching from Tom Cruise to Kevin Bacon, and it's just returning all of the names and of the movies and people in that path. So we're only using one index. The planner will only use one index by default. It will pick Tom Cruise or Kevin Bacon. And this results in 1,792 database hits. Now, database hits are units of work, abstract units of work that we can use to compare query performance independent of the hardware or network conditions at the time. So 1792 is a good metric. The database hits are a good metric to evaluate whether you've improved your query or worsened it. So in the second example here, we're going to use two indexes. So you can see underneath the match clause here, we have two using index hints, indicating to use the person 1 name and the person 5 name. So it's going to start at both locations, and then it will come to join in the middle at a point. So this limits the expansion from growing from 1 to 5 by simply finding starting points at both 1 and 5 and converging in the middle. And so this results in 583 database hits, a significant improvement. So using multiple indexes sometimes can improve performance quite significantly. So now I'm going to move on to a keyword called the Cypher keyword. So this is something you put at the beginning of your query. So if you were to run a match clause, you could simply put Cypher 2.3 and then continue with match. And this keyword will force the use of an older Cypher planner. So this can be useful when you're upgrading to a new version of Neo4j and you're trying to look at the performance of a particular query or queries, and that performance might have changed, and you want to see how that query would have been executed, the plan for that query, in an older version of Neo4j. So sometimes performance increases, sometimes it decreases, but it helps to roll back the execution of a particular query to an earlier version of Cypher so you can see if anything changed. Another keyword using Cypher is to indicate the rule versus cost planner. And this is something where you would probably not want to change it because the cost planner is much more intelligent than the rule planner. This is how we evaluate your Cypher into a plan. Do we just use a set of rules independent of the conditions of your database, or do we use the cost planner where we're taking into account all of the database statistics that we have accumulated? The only time when the rule planner might make sense is when the database is very small and growing, when we don't have significant statistics enough to make effective choices about how to plan your query. But for the most part, the default cost planner is always going to be more efficient. And the last one is the Cypher runtime keyword, and there isn't really much to say about this other than that we're working on improving the performance of the compiled Cypher code as it's executed in the JVM. Right now, it's processed a little bit more piecemeal and we're trying to consolidate the execution of the Cypher plan into JVM bytecode so that it can be optimized by the Java runtime. So I mentioned eagerness earlier, and so I'm just going to talk about that for a couple slides here. Cypher will process and return one row at a time, and that keeps memory usage limited. And you want to try and avoid processing everything in one big push. You want to process everything one row at a time, ideally. You will observe an eager operation in the query profile if an intermediate result must be evaluated across all rows before continuing. So what that means is that some subsequent operations depend on the result of an earlier operation. And so that entire earlier result set must be computed before continuing. So an eager operation in the profile, when you see it, it can take two forms. There's an eager aggregation, which is caused by any of the aggregation functions like count and sum or collect. And this is normal. It's of lesser concern. It's something that you can't really avoid because you want to be doing that. The other one is an eager step caused by a reference later in the query to an object modified earlier in the query. So as I said before, you're referencing something that is mutable and must be made immutable before continuing the operation. The for each keyword can also cause an eager aggregation in the profile, and it's also something that will affect load CSV. And so if you have a periodic commit in a load CSV, but you have an eager aggregation within that load CSV, or rather simply an eager step within that load CSV, it could end up ignoring the periodic commit. So here's an example of eager within the context of a query that you can run yourself. The second merge here depends on the result of the first merge, because the merge is going to look to see if a node exists, and if not, create it. But for all the planner nodes here, the node that is creating in the second merge statement could have been created in the first merge statement. So it's going to force the merging of all 10 nodes in the first line before continuing to merge the node in the second line here. And so you can see in the profile that we have an eager that is calculated before continuing with the result. There's also an eager aggregation at the end of the query where we assemble the count of all of the different records being affected. So one final point with the eagerness. I want to emphasize that this is absolutely fixable and is something where if you are able to separate this into multiple queries, then it will reduce the amount of memory being used by your operation. If we just execute this unwind merge for the first node, and then in a separate execution, execute the unwind and merge for the second node, we will have split the operation into two transactions and avoided the eagerness. So the eagerness it can cause excessive memory usage against large data sets where you're building up a very large intermediate state in memory. And with Neo4j, you really want to keep the use of memory as limited as possible. And so trying to avoid eager is something that you want to look for in your query plans to reduce the overall usage of memory in Neo4j and keep the space limited. So taking this query and splitting it into two queries would avoid the eager operation. And that's something that, in particular with load CSV, there's nothing against running load CSV multiple times on the same file. If it avoids eagerness, then you want to do it that way instead. So geographic distance, this is something where you can calculate the spherical distance between points on the Earth. So this uses a special type in Cypher called the point type. So in order to use the distance function, you must first create point objects in Cypher. So the point function takes as an input argument a map, and that map can have either x and y coordinates, or it can have a latitude and longitude coordinates. So the distance function will take two of these point objects you have created and calculate the spherical distance between those 2 points in meters. So you can see below I have an example where we're pulling down the latitude and longitude through use of a epoch spatial function, and we're putting those into a point function, resulting in a point object. And we're doing this for 2 points, the Golden Gate Bridge and the Statue of Liberty. So you don't have to use the epoch spatial function here. You can supply the latitude and longitude in the point function from your own applications. I'm just finding this data here for demonstration purposes. So we're able to calculate the distance here between the two objects, and it looks like it's about 4,100 kilometers. So now I have a few examples of Cypher and different Cypher patterns that I've used and you might find helpful. The first one here is to demonstrate how you can use collections and map objects in Neo4j in a nested context. So here we're finding people that co-acted in a movie, and we are collecting the movies, or the movie objects, into a movie's key, and then we're also supplying the actor, the pair of actors here, the name of the first actor and the name of the second actor. So the collection here will group by the person one name and the person two name, but this results in a single map object being returned, and it's a useful data structure. And to know that you can nest these collections and your group by columns within that data structure. So if you were to continue on with the result of the first query, you could continue aggregating on the pairs of actors as well, running a group by on the earlier collection. And so you're able to create complex collections and operate on complex collections in Neo4j very easily. So arrays are also a very useful data structure in addition to maps. The first example here is just showing how you can use nested arrays structures in Neo4j to save data. So this is a very common data structure for storing pairs of data in an intermediate operation that you then pass on for consumption later in the query. So this reduction here that we're doing is combining these results of the earlier arrays into a zipped array, which is a nested structure, where we're able to create an array of arrays. We can flatten that by using a further reduction of just iterating through the zipped array and concatenating it together into a flat array. So these kinds of data structures are very useful for passing along intermediate results, but you want to actually use them in context. So when you are trying to reference nodes from a collection like an array, you'll get an exception in Neo4j. So if you see the line, the fourth from the bottom, where it says it won't work, if you were to try and match the director of the second object in the array, the index 1, it's not going to work because it needs to be an actual reference to a variable, not a dynamic object. And so this is just a little tip that if you do plan on working with dynamic objects and arrays in Neo4j, you have to use a with statement to put the dynamic object into a variable, which you can then use in a normal match clause. So finding the root or leaf node is also a common use case where you're trying to follow a long pattern and just see how far it goes. And this is just a pointer that you want to simply, in the where predicate, say that the end node doesn't have a subsequent connection to another node. And I'm just pointing this out so that you don't do something like in the second query where you're doing a match star, which is to say all different connections between two objects, and then simply return the shortest one by length, or the longest one by length descending. You want to be able to only calculate and return the results that are relevant for you, not calculate a much larger result set and order it. So mirrored paths in Neo4j, the pattern expression, the result of a match, will not include duplicate relationships. So it will not go over the same relationship twice. But that doesn't mean that it can't display or it can't return the same two relationships transposed in a second result set. And so this is a common thing people forget, and they end up with duplicates in their query. It's just something where you see the line highlighted in blue down below, where you can indicate that you want the ID of one object to be less than the other. And this is just an arbitrary way of saying that you only want one of those two paths. You don't want the same path mirrored. So you can do this very simply by comparing the IDs. You can also do this in a second way down at the bottom, where I show you that you can order by a certain property of those objects and then collect them in a distinct way. So shortest path, I just wanted to mention a few things because sometimes people don't really understand what it's doing under the covers. But it's going to do a bidirectional breadth first search. It's very efficient search. It starts from both sides, so it gets around node density issues. It works with path predicates, all and none. So if you want all of the relationships to be of a certain set of values, or you want none of the nodes to have a certain property value above a threshold, you can include these, and it will work with the shortest path function very well. Anything that requires the entire result set to be calculated first before the predicate can be calculated does not work with the shortest path very well. And if nothing is found by the breadth first search, it will execute a fallback of a depth first search. So this is a completely separate additional search that is executed if it's unable to find a result from the first search. This can be disabled, the fallback search, using the syntax below where we execute a with clause. So if this is something you want to avoid in your application, you can disable the depth first search entirely. And so with that, we have the end of the presentation. And I know some of you guys have been entering some questions here and there, so hopefully we have some good ones.
Great. Thank you very much, Alex. As a reminder, we will be emailing out these slides as well as a copy of the video to the email address which you used to register for this webinar. We'll take a few minutes of questions here. And then, of course, if you have any follow-up questions, you can feel free to use your enterprise support contract to ask questions of the support team, or for community members, you're welcome to use Stack Overflow or Slack or one of the other many forums available to add additional questions. We're always here, always happy to answer your questions. So with that, I'm going to go through. We have a handful of questions from the audience, and I'm going to go through and ask some of these of Alex. So the first question here, Alex, is from Don, and Don asks, is scan a sequential traverse?
Using scan, we'll just pull down the whole set of nodes with that label and apply your predicates against that result. So,
will it use an index to pull down that set? If you have that label indexed, will it use an index to find that set?
well, an index can only be applied against a labeled node, but when searching for that node, it must decide whether to use either a index or a label scan. It can't do both. So if you're doing a label scan, it's just going to return all of the nodes in that label. If you're doing an index scan, it's going to say, for nodes of that label, I'm going to check that it has a certain property value.
Okay, so the next question, hopefully that helped Don, but if not, feel free to follow up with us on one of those channels that I mentioned earlier. The next question is, why wouldn't I match for P Olympian instead of a match for P person and Olympian using scan P Olympian? Sorry, I'm just showing this to Alex here so he has a chance to actually read the cipher rather than trying to say it verbally here. But
so the point of using P Olympian would be if there are a lot, there are a lot fewer of those than would be returned by the age comparison. So if you're saying that, and let me go back to the example
yeah,
here.
so everyone knows what slide this is referring to. Thanks, Alex.
So we know that there are going to be fewer Olympians than there are people age 18, and that will remain to be true. So if the planner is not using the Olympian label to begin the query, it should be, because there are 5,000 Olympians in the United States, and there are 5 million people age 18 in the United States. You want to start with the 5,000 because it's much more selective. So it's a smaller search space where you can then apply the age 18 comparison to those 5,000 nodes, and it will be much faster than simply returning a full index scan for those 18.
And what is the maximum number of hints or query time execution in millisecond that you recommend for good performance? And this question comes from Kevin.
Well, what defines good performance is very subjective and depends on your use case. I think that using hints is reserved for when the performance you're seeing is not meeting your expectations. However, the performance is often better remediated by changing the overall progression of the query, moving to reduce the intermediate result sets and reduce the amount of overall calculation being done. There is no maximum number of hints that I'm aware of. I haven't really tried to do anything like that, but if you tried to using index on a whole bunch of different nodes, the node hash joins that would result from that would end up degrading performance more than helping it. So you don't want to use more index hint. You don't want to just pepper your code with using index hints. This is not the path to better performance, because you'll see that the join operations that take place joining these different branches are also quite costly. So it will sort of reach a point of diminishing returns, if you will.
And those join operations are exactly what relational databases typically do. And the reason that a lot of people move to graph databases is to avoid those joins. So indexes are great for kind of finding the initial start points in the graph and then doing a smaller subgraph traversal from that start point. Is it part of your roadmap? Question also from Kevin. Is it part of your roadmap to apply sort in a union of two or more match queries? So I think you can actually accomplish this with a collect. I noticed we actually have some blog posts on the neo4j.com blog about using collect instead of union to then apply a sort on it. But I don't know if this is something that your customers have worked with, Alex.
Yeah, I mean, you're absolutely right. You can just simply collect the results of the two queries and order them by a certain value. You want to collect and then unwind those values, after which you could order them and then collect them again if you wanted to, or just simply return them ordered.
And a question here also from Kevin, which relates to a conversation that Alex and I had before the webinar, but he said, I'm not really sure I clearly understood the difference between compiled versus runtime, particularly in terms of performance. Could you please step back?
Well, so my understanding of this, and I'm not a member of the development team working on this currently, but it's that within the current runtime, we're aggregating a set of individual operations that we're then throwing uh, at the Java runtime independently. So sending an operation, waiting for a result, sending another operation, waiting for a result. Whereas with the new compiled runtime, the whole operation is sent in one go, and we get a result back. And having the entire operation executed at once in the JVM allows for some more optimizations between those different steps that are occurring.
Yeah, that's a great explanation. Thank you, Alex. And Rolf asks, thank you for the nice webinar. Where is the recording from the last webinar? So Rolf, I'll take a look at that. I don't know if for you folks that don't ordinarily show up to these webinars or are new to these, I'm a new host here. So I'm playing substitute teacher, but I will take a look and see if I can figure out what happened for you, Rolf, with the recording from the last webinar. And I'll just write down your name here quickly so that I can follow up with you. And so Alex, what's the trickiest thing that you've run into when writing Cypher? This question is from Bob.
I think sometimes just getting the order of operations correct is the most difficult thing. You want to do a lot of things, and sometimes understanding how to collect and unwind, when to use for each versus unwind, just getting the sequence of operations correct. But when planning complex queries, I think that anything is doable so long as you start small and you validate your result set as you move along. So if you're working on a complex query, just break it down into parts. Start by making sure the first part returns what you would expect, and then start adding and then make sure the intermediate returns what you expect. But yeah, I think that complex things in Cypher, where in other languages, particularly Java, it might be easier to just break it into a series of control blocks and conditionals. In Cypher, you have to sort of do a little bit more mental gymnastics to get that to work.
Thank you, Alex. And Kevin thanks you for your answers from before. And another question from Andrew regarding how to do post-union operations. You can use the APOX Cypher run procedure to perform union operations and then continue working with the yielded results. So that is a comment from Andrew about using the APOC library, which is an open source library of procedures running on top of Neo4j. And there's a way that he has used that to perform union post sort operations on unions. So thank you very much, Andrew, for your comment there. And let's see here. Someone asked if this is a recorded session, and yes, it definitely is. And for those of you who didn't hear the announcement earlier, we will email out a copy of the recording as well as a copy of the slides. A question about timestamps, which is a little unrelated, but are there timestamps, and are they set by user set as either European or US time, comparison of times, difference between dates and timestamps, etc. I mean, so we don't currently have native support for dates in the database, but oftentimes people use timestamps, which is time since epoch, time since January 1st, 1970. And do you want to talk a little more about that, Alex? Or?
No, I don't have a lot to add there, except that, in the context of working with timestamps, the epoch functions are invaluable. And the epoch time will just be calculated using system current time milliseconds in Java, which is the system time zone, I believe.
Yeah, but I mean, if you are doing an international application, you can certainly calculate that yourself based, in your application based off of any time zone that you choose to calculate off of, and probably recommend doing that in GMT if you have an international application, so everyone understands. In past jobs at companies I've worked with, though, like the Pacific time zone was their standard, so I think it probably depends on the company. Yeah, the APOC libraries are fantastic for this. Plus, since we added the ability to do range indexes on numbers, you can get really fast results from searching between ranges of timestamps. And even the starts with query actually sometimes becomes useful too if you want to store your dates and times.
Right, and that's an important point too, is that was dramatically improved recently, the range index searches. So it used to be that people would try and create these big complex time trees to solve these kinds of problems, but often now it's just not necessary. You can do range index searches. They're index backed, and they're much faster than having to do anything with time trees.
In general, what kind of situations would you want to use for each versus unwind? A question from Andrew.
Well, yeah, that's a good question. Unwind is going to, if there is nothing to unwind, it's going to terminate execution of the query. So if you were to unwind an empty array, anything beyond that unwind will not be executed. Whereas with a for each operates more like an if statement or something like that, where if you do a for each on empty collection, it will do nothing, but then it will pass execution to the next Cypher statement after the for each block. So the for each kind of sends a branch out for execution and then returns back, whereas unwind is in line with the execution of the main query.
Thank you, Alex. And how do you find the shortest path based on property or metric value? And we'll take another 2 or 3 questions and then wrap it up here.
Well, you would have to use, I believe, the Dijkstra algorithm in the APOC library to do that. So that's very easy to do. You don't have to do Java code. Just download the APOC library and then look at the documentation for that. It should be pretty evident.
Yes, the Dijkstra algorithm in APOC is really awesome. So definitely encourage you guys to check that out. Any hints for speeding / reducing memory on queries inherently requiring a full scan, i.e. a count of relationships by type or destination label stemming from a label? This question is from David. And I think largely that these are types of things to take into account as you're building your model. But Alex, do you have any suggestions on how one could reduce memory or speed up queries that definitely do require a full scan?
Well, avoiding eagerness would be one. I mean, it's difficult because it'll be executed single threaded. And so, I mean, if you wanted to get really creative, you could try and, find a way to break up the query into multiple executions that you could run in parallel on different threads, and then zip the results of those together in Java code. But I'd have to see the context of the query you're talking about. Usually there's efficiency to be had without trying to overcomplicate your life with multiple threads.
Yeah, maybe that's a good query to post on Stack Overflow or on like one of the Cypher help channels on our users Slack. You can go to neo4j.com/Slack, I believe, to sign up for our users Slack. And then the last question that we're going to take here is from Kamal. And Kamal asks, is it possible to have versioning in the Neo4j? Like if my graph evolves and I want to have a query as it existed 3 months ago, sort of like versioning in Git. We're ending with a complex one here, Alex. Do you want to take a stab at that?
Well, we can't version your Cypher, but the topic of versioning in the data model comes up quite frequently. And in that context, it's just a case-by-case basis of what it is specifically that you want to version. There is no, and there probably will never be, an overall version my graph on-off feature. But you can version specific things using a linked list such that when you change the data, you archive the old version, insert the new version, and pointing to the old version, such that if you want to see old versions of the latest version of that object, you can just simply follow that relationship back in time.
Yeah, that's definitely, we actually had a discussion yesterday about how to do that in a content management system, and that's exactly what we're planning on doing to keep track of versions. So thank you very much, Alex. This has been fantastic. A lot of great insights that you provided for our audience here. And again, we'll be emailing out a copy of the video, and we'll also be emailing out a copy of the slides. And check those out and follow up in the community on Stack Overflow, Slack, or Twitter if you have any additional questions. And we'll be delighted to answer those. And again, encourage you all to check out neo4jsandbox.com if you want to try out any of these things that Alex talked about here today without downloading a copy of Neo4j. You can just try it out in the cloud with some example data sets, Trump World, as well as data sets on the US Congress and the relationship between congressional members and bills and votes and things like that. So encourage you all to check that out. And until next time, have a great week. Thank you very much.
Thanks, guys.